Hello everyone, welcome to AAT Tech Talk. My name is Narala Siddhartha. My roll number is 20951A6744. My branch is Computer Science Engineering with Data Science as specialization. Today my subject is Design and Analysis of Algorithms. My topic is sorting problem and its complexity. So let's start. So I mainly divided the content into three parts. The first part is about the sorting techniques. The second part is about a sorting problem and its complexity. The third one is the time complexities. So let's start. First one, sorting techniques. So, what are sorting techniques? Sorting refers to the operation or techniques of arranging and rearranging sets of data in some specific order. A collection of records called a list where every record has one or more fields. The fields which contain a unique value for each record is termed as the key field. For example, a phone number directory can be thought of as a list where each record has three fields: name of the person, address of that person, and their phone numbers. Being unique phone number can work as a key to locate any record in the list. Sorting is the operation performed to arrange the records of a table or list in some order according to some specific ordering criterion. Sorting is performed according to some key value of each record. The records are either sorted either numerically or alphanumerically. The records are then arranged in ascending order or descending order depending on the numerical value of the key. Here is an example where the sorting of the list of marks obtained by a student in a particular subject of class. The techniques of sorting can be divided into two categories. These are internal sorting, external sorting. So internal sorting, if all the data that is to be sorted can be adjusted at a time in the main memory, the internal sorting, then it is known as the internal sorting method, and then it is said to be that the internal sorting method is being performed. So external sorting, when the data that is to be stored cannot be accommodated in the main memory at the same time and some has to be kept in auxiliary memory such as hard disk, floppy disk, magnetic tape, external devices, etc. Then external storing methods are performed. So complexity of sorting algorithms. The complexity of sorting algorithm calculates the running time of a function in which n number of items are to be sorted. The choice for which a sorting method is suitable for a problem depends on several dependency configurations for different problems. The most widely worthy of these considerations are the length of the time spent by the programmer in programming a specific sorting program, amount of machine time necessary for running the program, the amount of memory necessary for running the program. Efficiency of sorting algorithms. To get the amount of time required to sort an array of n elements by a particular method, the normal approach is to analyze the method to find the number of comparisons or exchanges required by it. Most of the sorting techniques are data sensitive, and so the metrics for them depends on the order in which they appear in an input array. Various sorting techniques are analyzed in various cases and named these cases as follows. There are mainly three types of cases found in complexities. They are best case, worst case, average case. Hence the result of these cases is often a formula giving the average time required for a particular sort of size n. Most of the sort methods have time requirements that range from order of n log n to order of n square. Types of sorting techniques. There are mainly 5 types of sorting techniques found. They are bubble sort, selection sort, merge sort, insertion sort, quick sort. So let's discuss about the bubble sort. So what is bubble sort? Bubble sort algorithm is used to arrange n elements in ascending order, and for that you have to begin with a zero index and compare it with the first element. If the zeroth element is found greater than the first element, then the swapping operation will be performed. That is, two values will get interchanged. In this way, all the elements of the array get compared. The below is the figure which describes and indicates the arranging in bubble sort. In the first figure, we can see that the elements are arranged in non in any particular order, not arranged in any particular order. In the second image, the 5 and 4 are compared. Here the 4 is lesser than 5, so these two places are interchanged and 4 is placed at 5 and 5 is placed at 4. In the next figure, the 5 and 3 are compared again, and the 3 is smaller than 5, so they are swapped again. Similarly, which is performed in this, and this is performed until all the elements are sorted in an ascending order. So here is the algorithm for a bubble sort. Algorithm bubble sort of list. So let's discuss about the selection sort. The selection sort is a straightforward process of sorting values. In this method, to sort the data in ascending order, the zeroth element is compared with all other elements. If the zeroth element is found to be greater than the compared element, the two values gets interchanged. In this way, the first iteration, the smallest element is placed at 0. The technique is repeated until the full array gets sorted. So we can see in the below figure which shows the how selection sort works, and in this case 3 is compared with all the elements in the list, and if 3 is 1 is less than 3, so 1 is placed at the first place, and so on is compared unless and until all the elements are sorted in either ascending order or in the descending order. So let's discuss about the merge sort. Merge sort is another sorting technique and has an algorithm that has reasonably proficient space complexity of order of n log n and is equally trivial to apply. This algorithm is based on splitting a list into two comparable sized lists, that is left and right, and then sorting each list and then merging the two sorted lists back together as one. Merge sort can be done in two types, both having similar logic and way of implementation. These are two down implementation, bottom up down implementation. Below gives figures. Figure shows how merge sort works. So this is the algorithm of merge sort. So let's discuss about sorting problem and its complexity. A sorting problem is a special case of finding a set partition. The elements are identified by their rank in a linear order for a given finite set. There is some permutation such that other partitions which do not completely sort the set are often of interest, such as finding the minimum element, the maximum element, the first k element, the first k smallest elements, the median, or as will be discussed here, the minimum and maximum elements. Algorithms which take unordered sets and produce the desired partition are fundamental to computing, making this area one of the most intensely studied both practically and theoretically. In the theoretical attacks, the principal unit of work has been the comparison. An algorithm is compared to some norm on the number of comparisons. The two norms of most interest are the maximum and the average. The maximum norm is the greatest number of comparisons the algorithm takes place over all the possible inputs. The average norm is the average number of comparisons the algorithm takes with respect to the uniform distribution of the possible orderings. The best algorithm for a given norm is the one that minimizes that norm. The goals of this is to demonstrate technique for providing algorithms optimal in the maximum norm and using the technique developed to exhibit a new algorithm for finding both the minimum and maximum of a set, which is then proven optimal in the M norm. So let's discuss about time complexities. So time complexity of a bubble sort. Bubble sort uses two loops, inner loop and the outer loop. The inner loop drastically performs order of n comparisons. In worst case, the outer loop runs the order of n times. Hence, the worst case complexity of the bubble sort is order of n into n is equals to order of n square. In the best case, the array is already sorted but still to check, but bubble sort perform order of n comparison. Hence, the best case time complexity of bubble sort is order of n. In average case, bubble sort may require n by 2 passes and order of n comparisons for each pass. Hence, the average case time complexity of the bubble sort is order of n by 2 10 is equal to order of n square again. Time complexity of the bubble sort is given below. The best case is order of n. The average case is small of n square. Worst case is order of n square. Thank you.